Hello and welcome to today's event. I'm Mike Pastor from Technology Advice. We live, as I'm sure you're aware, in an increasingly connected world, and in today's businesses, many of the data-driven experiences and applications our customers and employees use are made possible by APIs. And so, API security has emerged as a top priority for protecting vital data and services. Unfortunately, many organizations are just one vulnerable API away from a privacy incident or a data breach, and it's an area where many companies lack expertise. And so we're fortunate that today we are joined by Adam Fisher, Principal Security Engineer at Salt Security, who is going to share some best practices for API security. Adam has worked on cybersecurity projects for Fortune 500 companies and governments like the United States and UK. His full bio is in the About Your Speaker tab. It's at the top of your screen if you want to learn more about Adam. But take it away, Adam.
Great. Thanks a lot, Mike. Super appreciative. Thanks for your time, and thanks for having me on here today. So really looking forward to our conversation. Obviously, API security is where all the cool kids sit these days, right? It's the cool kid table in the lunchroom, and this is where everything seems to really be congregating around application security and how we protect APIs. I've had the privilege of being here at SALT for 3 years and have been in the application security space ever since WinNuke 95, came out during my high school years, right? And all the fun that Windows 95 provided from an application hacking and security perspective was obviously how I got into what I'm doing today. Today we're going to focus, like we said, here on APIs, and we continue to see the proliferation of APIs across our businesses. Any new company, any new startup that enters their business today starts on APIs. There's no concept of not being in the cloud, right? Nobody's starting up a new data center. All of these things come now back to APIs and how now modern and new applications are being created. Because of that, we are seeing this shift as well in the security space from the traditional security tools that we've been using for the last couple years to new and advanced ways to protect our different applications than the traditional websites that we're familiar with. Now, because of that shift, we've seen now specific cases where, we've seen breaches associated with APIs, attacks associated with APIs. And it's not that these companies didn't have robust security practices. It was simply that the traditional tools that they've invested in, aren't keeping up and haven't adjusted to how APIs are used and how APIs are developed. Now, the interesting thing with this is here from Gartner was that, they stated by 2022, APIs would be the most frequent attack vector, resulting in these breaches, and they really hit the nail on the head. They directly identified when this would happen. And it was one of the more, spot on, I guess you can say, quotes from Gartner and how we've seen API attacks today. So what we want to focus on here specifically are some of the best practices around API security and how we can help your businesses reduce the risk associated to this new attack landscape that is APIs, our API applications. So let's move forward here. These are some of the key areas that we will focus on today. First, API documentation, discovery, and cataloging. Why this is important, why we have to have that clear understanding of all the APIs in our environment. Runtime protection. How are we then going to be able to prevent our APIs from being attacked? How are we going to even see into the attacks that our APIs are facing? And then specifically around, being centric, being API centric in our security posture, and how we can move forward in protecting our APIs and really being API security aware. Excellent. Let's get going. So the first thing here that we always hit on is really the visibility aspect. We're familiar with this. We know that we can't secure anything that we don't see. We have to have visibility into our APIs and how they're being developed, how they're being discovered. What are we doing to, maintain really asset management around APIs? So, asset management is nothing new. Why is this more difficult for APIs? And the reason is the speed at which they can be developed. I've seen customers, I've seen business environments that have upwards of 50 to 60 API changes or releases a week. So as this agile methodology proliferates now across businesses, where they're able to move faster, develop faster, APIs has just become an easier way to move even quicker. There's lots of reasons for that technically with APIs, but just realize that you're going to have 50 to 60 API changes a week. That's not unheard of. So how, from a security perspective, can you adapt and have visibility into all of those changes that occur? So there's a couple things here that happen that are revolve around APIs that should be in place to make this easier. So the first thing is standardizing on the OpenAPI specification. This is how we're going to be documenting our APIs so that we have that visibility from a documentation perspective, in the pre-production phases to identify what APIs are being worked on, what's going to be released, and then being able to identify, any pre-production style vulnerabilities by comparing that against the OpenAPI specification, making sure that we're in line. Before the API is even released, we're releasing a secure API. Now, there's a couple things here around this documentation process, though, that can lead us into, I would say, maybe a false sense of security. Number one, just because you've documented your APIs doesn't mean they're secure. And number two, you have to continue to maintain that documentation over time. If you don't document correctly, right, you're going to release something that doesn't conform maybe to the OpenAPI spec or is not up to date. And so what is actually running then is actually not what we think is running. It's not what is documented. Now, the best things that I've seen here are those that have an automated documentation process. If we rely on our developers to do this, I'm going to be honest, it's just not going to get done. We're all humans. We're not going to get this documented. And, documentation is not the funnest part of anybody's job. And if they tell you that it is, they're not being honest with you. So we have to be able to have some way to automatically document these for us, compare these against the OpenAPI specification, so we're releasing good APIs. Now, there's lots of reasons, though, why we say up here, API drift. There's lots of reasons why over time, what is actually running, though, has deviated from what was documented when it was originally released or pushed to production. So we have to be able to take view or take stock in what is actually running in our environment and what we think is still documented.
So, Adam, you mentioned API drift. Things like drift and sprawl are not uncommon. These are not unheard of things in the IT world. We've seen it with web-based software applications that people can go and procure and put into the environment without going through maybe the proper procurement channels. We've seen it in the data center with virtual machines being created, being configured differently than maybe the plan, and being released. So I guess on some level, I'm a little bit surprised that because these aren't completely unfamiliar issues to people in the IT world, we still see them hit with APIs.
No, we still do. We still do. Asset management is, I think, going to be one of those forever problems that we face. But there's two things I've really seen stand out here in the API space. So number one is APIs get released either from, how can I say this, right? From a side branch. That we're creating something maybe off to the side that doesn't go through the normal, pipeline channels to get pushed to production. And so it doesn't follow that same automated documentation process. And, it was basically made like an out-of-band deployment. And I know people are probably, shaking their heads that, hey, that's never going to happen to us. I continue to see that. And then the second thing are, once something gets pushed into production, it usually never gets decommissioned. It never gets removed. And so here now you have, maybe an API endpoint or an older version of the API that is still running that could be accessible, but, at some point somebody thought it was decommissioned because it's a version 1 endpoint and you're on a version 5 or version 6. And it's very difficult. Usually nobody's brave enough to decommission, the endpoint. And that's really where I see this drift and the issues around asset management kind of, poke its head up.
Thanks.
Yeah, great question there, Mike. So, we've talked about this and how we want to maintain that flow. The next thing that really is beneficial and needed is really comes down to tagging and labeling the microservices consistently. So we want to be able to understand then, what is it that is running, maybe who the dev owner is, who the team is that's creating it. So when the SOC team, when the security operations team identifies an incident, they know exactly who to work with, who to contact with, who to wake up at 2 a.m. in the morning. All of that becomes really important so that you can quickly triage and identify any vulnerabilities that could exist inside that application. With API security, for me, it really turns into a security development operations team. You have to work closely with the dev team here to quickly triage and resolve any of the API vulnerabilities that will surface, any of those incidents. And without proper tagging, without proper labeling, that becomes more difficult. The next thing here is just overall lack of visibility into the API environment. And what really is required here is the ability to identify automatically and continuously the APIs running in your environment. Without automated discovery, let's say we do maybe some type of point in time scan. So Monday morning, we'll crawl the network and look for any additional endpoints that surface. Well, if every day I'm making 10 to 12 changes, 50 to 60 changes a week, by the subsequent Monday morning, when that scan's going to run, I'm already way out of date. And I could have had 6 days of exposures, 7 days of exposures occurring without me knowing it. So we have to be able to maintain an up-to-date catalog, like I said, that runs automatic and it's continuous. So as soon as that pipeline runs, as soon as a new API is changed, that type of detection, that type of change is detected automatically. The next thing is how granular we get. The difference here is that we can't simply just identify, oh, here's the domain name and here's the path for the API. We really have to be able to identify, down to the request, down to the response level of what that API is doing. That's the type of visibility that we need to accurately identify malicious traffic inside those APIs from a security perspective. So your security team really needs to have that type of granular discovery. It's not just, oh, over here's a URI endpoint or something like that. The next thing that is critical, and we're having customers now that are being specifically asked where sensitive data is, not just in their applications, but specifically in their APIs. So do you know what sensitive data is used in your API endpoints? And that is something, again, that we have to be continuous and automatic in our identification and discovery of our APIs. So from a security standpoint, when a new API is released, if that is exposing now highly sensitive data, you're going to be able to draw attention to that. You're going to have a focus on those riskier, more important endpoints that are accessing that sensitive data.
So the evolution that you're describing, Adam, is very similar to something you briefly touched on before, which is endpoint protection, and how we've gone from the weekly scan to preventing zero-day attacks, right, with a more active approach to protecting our endpoints. And it's applying this to API. So this should not be unfamiliar to a lot of security teams, because they've sort of already been through this evolution of the old way of looking for threats and identifying where there's vulnerabilities and sensitive data. And now they can apply it to their APIs as well.
Yeah, absolutely. It's not like we're talking about new requirements here for, an application security product, right? These are things that are must-haves in any, tool and security solution that you're looking to implement. You have to be able to have something that identifies this data, clearly spells it out, clearly describes very quickly where your sensitive data is being used in your application. So yes, absolutely, shouldn't be anything new, and should be on anybody's requirement list for their application security tool. Okay, good. So let's move forward here. We're going to look here now at the second requirement, which is runtime protection. Runtime protection, now that you have that visibility into all your API traffic, you're going to funnel up some endpoints. You're going to discover some scenarios where you're like, oh, we need to resolve that, but I can't turn off the application. And that's why there's runtime protection. This is what buys you that time to secure your applications while it's being resolved by the development team. So the real key thing here around runtime is, first, let's use the threats, let's use the tools that your API gateways, your API management provides. They're going to give you some basic controls around authentication, authorization. They're going to help with how your APIs are going to be, protected from like rate limiting attacks, from brute force style of attacks. Anything that's going to impact the service, this should be handled by the gateway. So let's continue to use those tools there, continue to use what you're using from an API management perspective, and maintain that where it should be. So get those good, border controls up around your application environment. So we're limiting those things as far away from the application service as possible. Moving on here, though, some of the next things we're after is not just doing rate limiting with rules. So what I'm saying here is that oftentimes we're familiar with blocking down, either it's a bot attack, it's brute force attempts, but all of that, really you have to have visibility into what your normal traffic flow is, and then how much traffic you're getting from those malicious actors. And in my background, working in application security, there was always a limit. Either I could set a limit on the request that the domain could handle, and if I wanted to get lower into the actual application path, something more specific than just the domain name, I was creating lots of rules and had to be, have some type of forethought, have to be able to anticipate what the attacker rate may be. But this poses a lot of problems. You have to be familiar with writing rules for whatever solution you're using, but two, you can only be as granular or only be as specific as your normal user rate, and then you start to impact normal user behavior. So you have to have a tool that is flexible enough to identify what the user behavior is for each individual API endpoint, and then can automatically set that specific threshold for each individual endpoint automatically. Why you want to do this is because each endpoint is going to be unique. You can't set some type of a rate threshold to block those types of attacks if it is, if each endpoint then is going to have a different rate, which it will. So you have to be specific in how you're identifying that malicious traffic and those attacks across all of your endpoints. So an example of this is something that we saw here with Finastra, where they were under an immense credential stuffing attack. And by being able to identify what the individual rate limits should be on each individual endpoint automatically, it became extremely difficult, if not impossible, for an attacker to evade those rate limiting style detections. Because any endpoint they went to, any different login page they accessed, we had already learned what the legitimate user rate was, and so getting around that was extremely more difficult than having some generic rate limiting set, at a higher level, say on the domain name instead of like the domain.com/login. By doing this, again, able to provide then direct insight back to the developers, back to the security team on exactly what's happening, and then having that automatically set without needing the security team to, proactively assume what the rule should be for the rate, allows us to immediately identify these types of attacks across APIs. So what's important here as well when you look at runtime protection is not just, rate limiting here is a great example, but there's a number of API attempts that are unique, API attacks that are unique to API endpoints that the traditional websites just don't face. For this reason, the OWASP Foundation came out with the API Top 10 for APIs to specifically highlight the differences between API endpoints and the traditional attacks that we're all familiar with. So when we focus here on security operations, really what we're after is how do we integrate the data that we're getting into the other tools that we have in our environment? How can we maintain the complete API lifecycle when we have different teams, different organizations that require this data? So the first thing is being able then to integrate with the current tools that you already have. So we have to be able to integrate into an ecosystem. We have to be able to provide insights into those other tools that don't have visibility into the API space, but will benefit from getting the telemetry and the insights that can be provided, that SALT will provide from having that visibility into the API applications. Where is the issue arising from? Is this a misconfiguration of the API gateway? Is this a issue in the development of the code? Is there discrepancies in what's running in between what's developed? All of this are things that have to get fed back into the team. Now, one of the big hindrances, anytime there's a shift in development and business needs, in new application technologies, such what we're seeing here by the movement to API-based applications, one of the things here is how do I handle now an additional environment? How do I handle additional alerts coming into my operations team? So one thing that is extremely important here is that we continue to eliminate what I refer to as the noise, the dirty internet traffic, the things that just funnel up and alert us to either non-important, non-critical alerts, and take our time and create that haystack of needles when we're trying to find the real needle that's trying to infiltrate our business. So one thing that is important here is being able to take a higher approach, if you will, to identifying the malicious actors in your environment. So the first thing here is being able to identify or take action, not just against an attack type. We've taken actions against attack types in the security industry for years. And all that does is when we block one attack type, the attacker doesn't hang his head and they go home. They just try the next attack in their playbook. And what the security industry needs to do is look at this from a different approach. And instead of trying to block an attack type, there needs to be action that can be taken against the attacker, against the actual attacker that is trying all the different attack types. By doing that, we get fewer alerts. Your team will get a minimal amount of alerts because now we're not alerting on every attack type, but on the single attacker. And when we alert on the attacker, that allows us then to take action to block on that specific attacker. And this can be done in a number of different ways. Various tools handle this differently, but we want to be able to identify a commonality, a correlator, or an attacker fingerprint, if you will, that when we block on the fingerprint, we're mitigating whatever attack type that attacker is going to send. And this is a more direct action, it's a more definitive action that helps us sort through that noise and reduce the false positives of the various different attack types that could exist. And so here now we have a clearer view of the actual individual or individuals that are launching those attacks.
Adam, how would you rate most organizations' visibility into their APIs? Visibility has been kind of a key issue in security as our security postures have evolved throughout the IT industry. But APIs are a little newer. And, obviously we've talked about some of the risks that exist that people may not be aware about. So how much visibility do you think most organizations have?
So it's 10x is my response to that. A company is usually 10x off the total amount of APIs they have. So if a company thinks they have 100 APIs, they probably have 1,000. If they think they have, 10 APIs, they have 100. They're usually always off by 10x the amount of APIs they really have. Yeah, great question, Mike. So moving forward here, one of the things we see here in relation to this, into this, correlating of activity, identifying an attacker instead of spending our time chasing attack types, is being able to reduce the amount of alerts, being able to provide a dedicated quick action for the SOC team to take. It's a much more clearer explanation of what the attack is. But then more importantly, being able to identify in the beginning of the attacker framework, in the reconnaissance phase of an attack, of what an attacker is doing. So when you're using machine learning, when you're baselining user behavior, when you have automatic visibility across all of your APIs, you're going to know right away when an attacker is starting to probe and send anomalous data to your APIs. And so before an attacker is even identifying a vulnerability, there's that work that they have to do to identify the vulnerability. It is in that stage, in that recon stage, that we can now begin to identify attacker activity. So we're able to get super far in advance of any exfiltration attempt in our applications by those attackers. And so this allows your team to react quicker, to really identify that malicious behavior before it turns into an exfiltration attempt. So how do we do this then? The first thing here that SALT does is we identify all of your network traffic. We want to take all of the traffic coming in either from your load balancer on the edge, maybe some of your microservices, or from a gateway. We gather that traffic, and out of your network traffic, we're going to identify all of the APIs that are running in your environment. From here, we take that data and we run that through our machine learning and big data algorithms. This is where we then begin to identify and baseline the normal behavior for those APIs, literally across millions of different parameters and data points. We will baseline that behavior. And from this, we then gather the context of your APIs. How are your APIs used? And in this, we begin to identify then any of that malicious traffic that is anomalous and is not conforming to that normal baseline. Salt is the only patented API security solution today that leverages big data and machine learning to secure your APIs. Now, above this context architecture, we have those three key services that we've been discussing here during this webinar. We've got the discovery piece, automatic and continuously identify all of those APIs running in your environment. We then have that shield right, that runtime protection where we identify any malicious traffic, and then increase that security posture through protection, through runtime, through that feedback loop to your development team on exactly what needs to be protected and secured. It's been great here presenting with you. We have some additional resources that we can make available, and really looking forward here to working with you as we move forward.
Thanks, Adam. Good stuff. I have one last question for you I was thinking about on that last slide, and that is when prospects engage with Salt and you talk to people about becoming a Salt customer, where do they fall? Have they had a problem with their API security and now they're looking for help? Are they aware of the problem and they're trying to get ahead of it? What are the most common scenarios?
Yeah, great question. We really have a little bit of both. We continually see, companies, the newer companies that are a little bit young in their journey, in their business development, are starting out, but they are 100% APIs, and so they're coming to us to get ahead of it. We're the first security tool that they're going to bring in because they're 100% API focused. Some of the more larger enterprises, more legacy enterprises are coming to us now to usually play catch up because they have a bigger target on their back, pay a little bit steeper price for popularity sometimes, and now they're looking to, prevent any of the API attacks that they might be experiencing in their environment. Yeah, so we'd love to have you come and take a deeper dive with us. Come out and check out Salt. There's a number of things that we'll have out there on our website, some good articles, and really looking forward to expanding our conversation with you again. Thanks for your time, guys.
All right. Thank you, Adam. Great t-shirt there on the previous slide. Adam Fisher from Salt Security, thanks so much for joining us today.
Glad to be here, Mike. Thank you.